Good day, viewers. Welcome to my YouTube channel, Master David. I'm Victor Adewale Adeleke. Here, my major focus is teaching mathematics from the onset even up to tertiary institution. If you are yet to subscribe to my YouTube channel, do well to subscribe, like, and share. It is very important so that when I post materials like this, you will always and certainly get notified. Okay, we have a very beautiful question we want to quickly find the derivative of. Okay, we have that y is equal to the square root of x. Okay, how are we going to provide solution to this? I'm going to show you two different ways to prefer solution to this question. Then I can give you a bonus or an hint on how to solve it with another way, making it 3. So probably any one of which you desire, you can follow through. Okay, now what are we going to do here? It is very simple. The first thing to do is to understand that we have to increase the value of what? Of y. And if you are doing that, increasing the value of y, you have that y, this becomes y plus what? Change in y equals to x plus change in x. Now, once you've had this, the next thing to do is to what? Is to move the value of y, because don't forget we're looking for what? For dy dx. That is the what? That is the major conjecture of what? Of calculus. The definition of a. If you check my formula when I was proving it, I explained it that we are looking for dy dx, which is the same thing as what? As dy dx. This is the same thing as that. So what do we do here? Let's quickly provide solution to this. Let's see what we can do quickly. Moving your y to the other direction, we have what? That change in y will be equals to the square root, okay? The square root of what? Of x plus change in x, then subtracting y. And what is y? Okay, let me put your y first. This is it. So we have moved our y over to this direction. But what is y? Y is equals to what? The square root of x. The square root of x. Once you've had this, now the next thing to do is to multiply simply by 1. So person will tell me, this is the most stupidest thing or the most foolish thing that I can ever imagine. No, it is not stupid. It is a very smart thing. What is the 1? The 1 can be, 1 could be anything. 1 could be, whenever we have a divided by a, sorry, is 1. So we are going to rewrite this, but in this time we're going to take the conjugate of this number. What is the conjugate? Whenever we have the square root of a plus the square root of b, the conjugate is going to be the square root of a minus the square root of b. This is the conjugate of what? Of this side, and this is also the conjugate of this side in reverse, vis-a-vis. So once you've noted that, now let's quickly take that here. Let's take the conjugate of what? Of this question here. So to doing that, we just have that change in y becomes equal to, okay, let me put our normal parenthesis here. So we have x plus change in x minus, yes, our change in x. So multiplying what? We can say this x plus change in x plus this as the conjugate of this, all divided by x plus the change in x plus what? Plus x. So this is the same thing as 1. Of course, this is the same thing as 1. So from here we can expand. Don't forget, this is going to multiply the what? It's going to multiply the numerator. And if you are expanding bracket, do not forget a plus b multiplying a plus c is going to be a multiplying what? Everything here, a plus c, and plus b multiplying the same everything here, a plus c. This is the system of expansion. So that's what we're going to apply here now. So doing that, we are going to have that change in y. Okay, let me try to break it down. Let me try to show everything. Change in x plus this will multiply everything. We have x plus change in x, then plus another change in x, yes, then minus your square root of x, still multiplying the same thing, x plus what? Change in x plus your change in x. Okay, then all divided by this, x plus change in x, okay, then plus what? Plus our x. Yes, so we have expanded the numerator, leaving the denominator the same, nothing spoils. So what happens now? We spread or distribute this value into the brackets. So when we do that, we have that change in y becomes equal, this multiply this, the law of surd that says whenever we are multiplying the same values that are having a surd or a square root on top of them, they must come out to become what? just one of the values. This is a system of operation for sod. So that's what we're going to do here. So when this one multiplies this, we're going to come out to be, it's going to come out to be what? X plus change in X. And this multiplies this. We have change in X, or multiplying X plus change in X. The same thing happens. We have minus X. Then we have X plus change. Sorry about that. Then minus. Why minus? Because plus times minus, or minus times plus, is the same as what? As minus. So square root of X multiplies square root of X, just like I've explained, simplifies to be what? X. So all divided by what? You are leaving your X plus change in X. Okay? Trying to be as clean as I could. All divided by X. So what happens here? You can see X dot what? Eliminate X, and positive, all of this eliminate negative, all of that. So which means minus 6 plus 6 will be the same as 0, or plus. Let me put the same way it was arranged on the board. Yes. So that's it. So positive, all of this, minus, or taking negative, all of this, eliminates to what? To 0. So once we've done that, I think what we have left is just the change in X. Okay, we have change in Y with respect to change in X becomes equals just your change in X, all divided by change in X plus, sorry, X plus change in X, then plus your change in X. Now once you've added that, let's take limits. So let's take limits. So if you are taking limits, I'm trying to minimize my space. Okay, let me just go over to the next. Okay, if you are taking your limits, you have change in Y with respect to change in X, limiting the denominator, limiting what? Change in X to 0. You are going to come out with, mind you, the denominator is what you are taking limit of. So you are going to come out with dy dx, which is equals to, okay, I think we've jumped a step. So what we are supposed to do, what we didn't do was that when we divided here with change in X, we are supposed to also divide here with another change in X. Absolute. So this eliminates out this. Because don't forget, there was no change in X here. So for you adding change in X, the good rule of mathematics, don't forget that it must not be broken. So you must multiply both sides, or divide both sides, with change in X, which also happens to the right hand side, and they eliminate out to become what? Just one left. So you're having your 1 there. So I'm going to have what? 1 over the square root of X plus 0. Then plus the square root of another X. So finally your dy dx is going to be equals 1 over square root of X plus another square root of X, which simplifies to become 2 square roots of X. So that's the solution. Square root of X plus square root of X. If you don't understand how square root of X plus square root of X became this, now I can just give you a trick like this. What is common? Square root of X is common. So factorize square root of X. So what is going to be in the brackets such that when this square root of X goes back into the bracket, it comes back to the question. So the only thing that can be there is 1, because square root of X times 1 square root of X. Then square root of X times another 1 square root of X. So it returns back to the question. So 1 plus 1 becomes 2. Okay. So 2 times square root of X, we have 2 square roots of X. So that is a system of operation that you can keep in heart, so that you don't get confused when you see stuffs like that. Okay, now let's see what we can do again. This one system or a school of thought that can be used to provide solution to this, a school of thought, like I said. So let's see another method, an alternative approach that could be used to provide solution to that. So we can say y equals to x squared. We can say this x square root of x is written as x to the power of half. So we can say y is equals to the power of half, multiplying both sides by 2, here is to the power of 1. The good rule of mathematics, so happen to the right hand side, happen to the left hand side. So we have this. So 2 eliminate out 2, and we are having that y squared, trying to be as clean as I can. Y squared becomes equal x. This is it. So from here now we can take our derivative. Taking our derivative, find the increment in both sides. So we have y plus the change in y. Let me try to be very fast and smooth here. X plus change in x. Yes, let's be very careful now. Expanding this, you can do that. Check it out. When you expand this, you are going to come out with 2y change in y plus the change in y all squared equal x plus what change in x. So what is y squared? Y squared is what x. So you have x plus 2y. Okay, 2y change in y plus change in y all squared equal x plus. Okay, we have x here, we have x here, so they can eliminate, or you can see it comes here and it becomes 0 at last. So it's the same thing. So from here, what do? We have 2y change in y plus change in y all squared equals change in x. So dividing all through by what is common? I think we have too much change in y. So dividing here by change in y, and here also by change in y, and here change in y. So we have this eliminate. We have 2y plus this. We have twice 2 change in y's here. So we have 1 under at the denominator. So it divides through, and we are left with a change in y, which is equals to change in x. Sorry, change in x with respect to what? Change in y. So you can see that, like I said, the denominator is what we take the limit of the denominator. So I'm going to take your limit here. So when you are taking your limit, change in x with respect to change in y, limiting change in y to 0 will become dx dy. And when we do that, dx dy, we are going to get 2y plus what's change in y now, it has been limited to 0. So we have 0. So we have that dx dy, is equals to what? 2y. But don't forget, we are not told to look for dx dy. We are not told to differentiate x with respect to y. No, we were told specifically to find the gradient, which is the information that I've explained in my previous classes in calculus. If you have not watched those videos, go and check, hit on them, and you are going to be broadened. You are going to be like, more of these things are going to be explained to you. So just go and check on them. They are very important. They will open your mind to what I'm doing here. So that's what we're going to do here now. So this is change in y, so delta y, delta x, which is what? Which is the gradient we are looking for. And this is the formula for gradient. We are looking for the change in y with respect to change in x, y2 minus y1 divided by x2 minus x1. Yes, that's what we're looking for. So that's what we're going to look for here. And don't forget, this is over 1. We can write this to be over 1. Mathematics is such that you can write mathematics in any way such that the assertion remains very correct, just like what we did here. You can see 1 was here. We just said, okay, we rewrote this one to be like this, which is still the same. So there's nothing spoiled here. So 2y divided by 1 is equal to 2y. Nothing has gone wrong. So switch becomes dy over dx. You are switching to 1 over 2y. Yes, you are done. That's the answer. So therefore, dy dx is equal to 1 over 2y. So this will be saying, but 2y was not what we got at first. Yes, it's very correct. Do not forget, y is equals to the square root of x. So you can simplify that and say y dy dx will be equal 1 over 2 square roots of x. Now, it's either you use this or you use the definition of a derivative, which I've already explained, that dy dx must be equals to the limit as h tends to 0, function of x plus h minus the function of x, all divided by h. So therefore, dy dx will be equals to, as taking the limit of h as it tends to 0. Mind you, we've got to the function of x. What was the function of x? The function of x is something as something as square root of x. Yes, that's the function of x, because that's something as y. Yeah, if you have done function in mathematics, function is referred to as y. Yeah, so you can rewrite that to the function of x. So that's the question. So therefore, function of x plus h is certainly going to be what? The square root of x plus h. So which means that you can substitute that now. Instead of writing function of x plus h, write this, the square root of x plus h, then minus function of x, which is the square root of x all divided by h. This is just the same thing as we have there, as we have here. So all you need to do here is to do what? Is to take your conjugate, multiply beta by your conjugate, which is this specific conjugate. I don't want to continue because it will end up becoming like this and we'll still repeat the same process. So this is how to use. So maybe you are thinking that this method that I've been teaching does not apply. Maybe you are stumbling on my videos and you are thinking the method I'm teaching here does not apply with that. Certainly they are all compatible. They are very together. They are alike, similarity to each other. So you must understand that. So if you are taking your conjugate here, it's going to apply the same here, and finally it's going to be simplified to become dy dx over 1 over what is square the 2 square root of x. As simple as ABC. If you are yet to subscribe to my YouTube channel, do it to subscribe, like and share this video. It is very important so that whenever I post helpful materials like this, you will always certainly get notified. Stay tuned.